Hello, my name is Ken Eaton, and today I'm going to give a demo on monitoring CA Datacom muff instance with SYSVIEW. First thing we're going to do is an anchor on the muff instance we want to look at, and we're going to do DC task command to see what work is running. You can see we have lots of work running now. I'm going to see if anything is running with any kind of delay, and we sort on duration, descending, and we have pretty much everything's running. There's hardly no delay. We have a couple of 1-second guys pop up. You see things running very, very well in this picture muff in terms of no delays. Next command we're going to do is deallocate. And we're going to do a command called lmid, is a line command. And we're going to display the fixes that you may, this picture muff is executing from this library. And you see the column fix level. We will sort on that, descending, and you'll see the list of fixes we have, and you also got some test fixes on. Down here we have the PTFs, and that's how you would, in an example, look for fixes by module by CSEC. Next command we'll do is we'll do a sort on IOCT, which will give us the total IO for a given data sets. And you'll see these over here, the column. This is the column you're looking at here. It tells you what data is doing the most I/O. And this gives you a class of problems you can go research or go investigate. Sometimes you want to know what's doing I/O currently. So we'll do this. IORT descending. And you see the I/O rates here for descending. Who's doing the I/O currently? These guys right here. And see, these are guys who are currently doing I/O. So if you're trying to find a problem with doing I/O, this is a guy to look at that kind of information. Next command we want to do is task. And this gives us a tree structure of Datacom muff instance. And here's the muff module. Here's the main subtask going under him. These SMA guys are the guys doing the real work. SMP task-wise, and you see CPU times accumulating. And down here is the minor subtask. As we hit enter, these times will change as work runs against a multi-user. Next command we want to do is DC task. Again, see if most any new work is doing. Duration time, again, we'll do descending. And again, we're showing the work not being delayed by much. And seems to be flowing right through just fine. Next command we want to do is do a DC log. Let's just look at the control block for the log, see what activity is going on, and we can see records going up. You see it here. You see the restart blocks we're doing because our pipeline is flowing. But this is showing works on the log just fine. Next command is DC rate. That command gives us the requests he's done. In the last 2 minutes, done 23,000 requests, and here's the reads, writes, last 120 seconds, what this is for. This gets redone every 120 seconds. It's like a heartbeat type thing. Next command is DC buffer. And then this historical data has been some muff spin up. This gives you an idea of some ratios you may want to do from the +5 to +1 to see how you're doing performance-wise. Again, this is historical, so you'll be taking that in context when you do these numbers. Next command we'll look at is DC return code. This gives us DB return codes. These are return codes you may want to investigate for problems you may have with your database areas, or why it's getting these return codes and do some research. Again, this is cumulative since it must spin up. Next one is SQL codes. And this gives you return codes for SQL. Next one we want to do is DC area. This command will show you the database areas by what we know by Datacom. And one of the columns I'll look at is is inserts, which is basic overflows, number of edits since you last loaded it. So we do a sort inserts descending, and that's number of edits. You see that the guys pop at the top. Next column that might be interesting to you is moved rows. And the reason this is interesting, this is where a database had to find space to move a row. And what can cause that is compression on a particular table or a multi-tabled area will cause us to move rows. Now the column is interested to us, extend. Who has dynamic extend turned off? So we'll do that ascending. You'll see these areas here don't have it turned on. But as you go down the page, you'll see we haven't gone to user databases. And another column of interest to some sites who happen to use still URI is you sort URI ascending, and these particular areas don't have URI on. Those may or may not require attention depending on how your applications are running. Another command is DC dsets, and this lets us look at the data sets that's in the CXX. And this is sort of like a type A report in some respects. You'll see the percent full. Over here you'll see the max percent, and you can sort on that column, max percent. And that gives you an idea of these data sets are full, they have a reason to investigate. The test I'm running is causing this to occur, so I'm trying to drive this test because I'm trying to test extends. So you can see the percent full. And you can do a sort on block sizes to give an idea of different block sizes your shop is running. And you'll see I've got to handle these block sizes in my buffer pools. So if you have multiple buffer pools, you can allocate specific buffers to each block size, or you can have them in a common pool, like plain data and data 2. Another command to look at is going to be the private command. And here, this particular display will give you 31-bit storage up here, and the column of interest to you is high watermark, and the list here is 24-bit PVT here, and again, it's high watermark of interest in this. And if you look over 64-bit, we do a G private command, and this top line right here, summary here, tells you how much storage multi-user is using for 64-bit. And here's how we get me into storage. And as you can see, the smallest increments of 1 meg. Next command we're going to do is to go back and look at Muff again, see if he's still moving along. And he's running just fine. Running lots of work. Some duration still popping up. Those seem to know anything of interest here. Next command is CPU. I want to show you. And as I hit enter here, these two jobs right here are my applications running, but there's no Muff job name in here. And there's my Muff. He's in here twice. He's in CP and zip. You see him running. So it gives an idea of how hard what CPU's Muff is rotating through as it runs the work. Next command to run is delay. And this command will show you what resources any job is waiting on. If your Muff is in here, this is not necessarily good news because your Muff is probably delayed for some resource. In this case, I don't see DSN-MuffX in here. It's at the top, sorry, it's been delayed 95% of the time. And that's bad news because this service class is not letting him get the resources he needs. And we have device delays, which means DASD seems to be an issue too, probably. Last command I want to show you is DC list. This command will list you all the Muffs in the particular LPAR you're on, and you can have more to go look at. And you'll see down here this dispatch of what different Muffs are running, who's running real work. So, but thank you for your time, and